The familiar architecture of our seasonal expectations is collapsing. On this 17th day of June, 2026, a profound atmospheric paradox is unfolding across the North American continent, completely dismantling the standard meteorological rules most of us have taken for granted since childhood. A single massively overloaded planetary wave pattern has initiated two massive geophysical anomalies simultaneously, separated by 1,000 miles, but bound by the exact same structural mechanics. To the north, a synoptic configuration that strictly belongs to the volatile transition period of April is currently spinning violent tornado supercells across the American Midwest. Simultaneously, down on the Gulf Coast, the first-named tropical system of the Atlantic season, Arthur, is defying the core laws of hurricane thermodynamics. It is holding its structural integrity over solid ground, threatening a multi-state trajectory before re-emerging on the far side of the continent. The critical diagnostic question that must be answered is clear. What specific state of the global climate system simultaneously produces an extreme springtime tornado outbreak and a rule-breaking tropical anomaly on the exact same calendar page? This investigation requires looking past localized alerts and analyzing the true systemic deficits occurring within our atmosphere. The National Hurricane Center has officially upgraded this system, and while its initial coastal velocity metrics appear unremarkable, its structural behavior is unprecedented. The deterministic forecast models are projecting an evolution that violates fundamental textbook physics. Instead of rapidly decaying due to land surface friction and the severance of its marine energy supply, Arthur is projected to maintain its low-pressure core across hundreds of miles of the Deep South, eventually undergoing secondary intensification off the Carolina coast. This anomaly forces a strict binary conclusion. Either our foundational understanding of tropical dynamics is incomplete, or an extraordinary, unrecognized thermodynamic reservoir is actively sustaining the system from the land surface itself. As the low-pressure heart of Arthur makes landfall near the upper Texas coast, its internal architecture reveals a highly disorganized, lopsided configuration, with high-altitude wind shear displacing the core convective activity far to the east over Houston, Galveston, and western Louisiana. Yet, this apparent disorganization is an aerodynamic trap. This displaced energy is actively priming the regional landscape, setting the stage for an extended inland survival mechanism. What specific physical properties are allowing a tropical cyclone to bypass its structural limits so far from the open ocean? And how does this undying storm connect to the violent structural collapse of the atmosphere currently occurring 1,000 miles to the north? To understand the mechanics of this anomaly, one must first isolate the standard physics of a tropical cyclone and observe exactly how solid ground is engineered to neutralize it. A hurricane is not a static object. It is a thermal engine that operates strictly on a continuous fuel loop. The core energy source driving this process is warm ocean water, specifically requiring a deep thermal layer of at least 26 degrees Celsius, or approximately 79 degrees Fahrenheit. As surface water evaporates into the lower boundary layer, it converts sensible heat into latent heat of vaporization. Invisible, stored thermodynamic energy. When this moisture-laden air ascends into the core of the storm, it cools and condenses into towering cumulonimbus clouds, releasing that immense latent heat back into the surrounding atmosphere. This localized warming lowers the surface barometric pressure, which in turn accelerates the horizontal pressure gradient, drawing in more maritime air to amplify the cycle. The scales of this process is immense, as a mature system releases an energy budget each day that completely dwarfs total global electrical output. This is why the depth of the ocean's warm layer is vital. A shallow skin of warm water is easily disrupted by wave action, whereas a deep column provides an unyielding fuel reservoir. Landfall is designed to instantly shatter this loop through three distinct structural mechanisms. First, The primary marine fuel line is severed, replacing the evaporating sea with solid ground that cannot supply moisture at the required rate. Second, surface roughness increases dramatically due to forests, buildings, and topography, introducing kinetic friction that disrupts the precise low-level inflow the engine relies on. Third, the ingestion of dry continental air acts as a thermodynamic poison, collapsing the internal thunderstorms from within. Under normal conditions, this three-part defense works rapidly, degrading a violent hurricane into a disorganized remnant low within 24 to 48 hours. This predictable decay is why the National Hurricane Center initially projected Arthur to weaken into a routine tropical depression as it moved inland over Louisiana and Mississippi. However, a critical misconception remains. A weakening wind profile does not equate to a dissipating hazard. The historical record demonstrates that weak, slow-moving, unorganized systems frequently trigger catastrophic freshwater floods far from the coast because they still carry an entire ocean's worth of moisture. Yet Arthur is refusing to execute even this standard degradation. The predictive models are tracking a system that somehow maintains its structural equilibrium over hundreds of miles of dry land. Because maritime evaporation is physically unavailable, we are forced to confront a singular, highly disruptive reality. The land surface itself has begun to mimic the thermodynamic behavior of the ocean, keeping the internal engine burning through a mechanism known as the brown ocean effect. The mechanism allowing this anomaly to manifest is known in scientific literature as the brown ocean effect. Formalized in pioneering research by scientists Teresa Anderson and Marshall Shepard, this phenomenon occurs when soil so heavily saturated with water behaves thermodynamics-wise like a shallow, muddy extension of the sea. Under specific conditions, the land stops acting as a physical brake and instead functions as an alternative fuel tank, supplying the latent heat flux necessary to keep a tropical engine running hundreds of miles inland. For this transition to occur, three strict environmental criteria must be met simultaneously. First, the lower atmosphere must mimic a pure tropical environment, exhibiting minimal temperature variation across the landscape. Second, the ground must possess an abundant reservoir of soil moisture right at the surface. Third, this saturated ground must release its moisture upward as latent heat, duplicating the evaporation process of an ocean basin. When the high summer of June beats down upon this waterlogged terrain, it drives intense surface evaporation. In a strict physical sense, a vast expanse of the deep south is transformed into a shallow continental sea, brown instead of blue, which the storm can drink from continuously. This is the exact environmental matrix being assembled along Arthur's projected path. The storm is not entering a dry landmass. It is tracking directly across Louisiana, Mississippi, Alabama, and the Florida Panhandle in the middle of a massive multi-day deluge. The soil is completely saturated, and the ambient air mass is dripping with high humidity from the surface upward. This is not a theoretical abstraction. The historical record contains a definitive precedent. In 2007, Tropical Storm Erin made landfall in Texas as an unremarkable system and initially weakened on schedule. Yet, 48 hours later, while positioned far inland over the plains of Oklahoma, Erin stunned the meteorological community by completely reorganizing, developing a visible eye on radar, and generating destructive hurricane-force winds and torrential rainfall. Erin proved conclusively that waterlogged soil can sustain or amplify a dying tropical cyclone. When we overlay Erin's historical data onto Arthur's current tracking metrics, the structural correlation is precise. While the exact scale of Arthur's inland intensification remains a point of active forecasting debate, the physical ingredients are undeniable. This brings us back to a deeper systemic reality. The brown ocean effect cannot occur in isolation. It demands a highly anomalous, moisture-loaded atmosphere across the entire territory. The saturated ground feeding Arthur is part of the same overloaded atmospheric column that is generating violent tornado supercells 1,000 miles to the north. These macro-ecological adjustments are not isolated events. They are regional expressions of a single system operating under extreme loading. To comprehend the full trajectory of this crisis, we must trace Arthur past this continental reservoir to the eastern seaboard, where a completely different layer of atmospheric physics is waiting to initiate a secondary, high-intensity reload. Assuming Arthur successfully utilizes this continental brown ocean to maintain its structural equilibrium across Mississippi, Alabama, and Georgia, it will eventually arrive at the eastern seaboard of the United States. It is here, over the Carolinas, that the predictive models introduce the most improbable phase of the forecast sequence, a secondary deepening of the system, a marked escalation in core intensity, and a restructuring capable of triggering fresh tropical storm warnings as it slides back over the open Atlantic. This late-stage reorganization cannot be attributed to the brown ocean effect alone. Instead, it marks a transition to a completely different layer of atmospheric physics. To observe this mechanism, the analytical focus must shift 35,000 feet upward into the upper atmosphere, where the fast-moving currents of the jet stream are operating. As Arthur reaches the Atlantic coast, a deep upper-level trough is dragging an accelerated ribbon of the jet stream southward, positioning these high-velocity winds directly over the vertical column of the storm. This spatial alignment initiates a process known as divergence aloft, which acts as a powerful mechanical pump. As the jet stream sweeps across the top of the atmospheric column, it evacuates air out of the upper levels faster than it can be resupplied from below. This rapid dispersal of mass forces a sharp drop in the total weight of the air column, causing barometric pressure at the surface to plunge. This collapsing surface pressure acts as an engine jumpstart, aggressively pulling in low-level air, intensifying the cyclonic circulation, and forcing a rapid expansion of thunderstorm convection. This upper-level dynamics handoff is immediately reinforced from below as the system moves over the warm shelf waters off the southeastern coast, re-engaging with raw maritime fuel. This sequence represents a highly coordinated atmospheric relay, where three distinct physical mechanisms, saturated soil, upper-level divergence, and marine heat flux, pass the system from one to the next across thousands of miles. From an institutional standpoint, meteorologists are openly debating whether this reloaded system will technically retain its pure tropical designation or transition into a hybrid or extratropical system, drawing its energy from steep thermal contrasts akin to a winter cyclone. For populations residing along the Carolina coast, however, this classification is entirely academic, as the physical impacts of wind, rain, and dangerous sea conditions remain identical. Furthermore, this structural progression is tied to an active moisture conveyor belt. Long before its core reaches the east coast, the high-altitude winds shearing Arthur are exporting massive amounts of tropical moisture far downwind. This configuration mimics a precursor rain event, where a slug of high precipitable water interacts with a frontal boundary ahead of the storm, generating catastrophic flooding rain in regions the center of the cyclone has not yet reached. In essence, Arthur is executing a self-feeding cycle, laying its own thermodynamic pavement by saturating the soil ahead of its trajectory, which in turn primes the brown ocean required to keep it alive until it intersects the jet stream. This self-perpetuating behavior indicates a highly primed, fully cooperative ambient atmosphere, providing fuel at every single juncture. This brings our investigation back to the overarching macrosystemic reality. Arthur is not an isolated event, but a single component operating in lockstep with a wider continental imbalance. To map the true dimensions of this crisis, we must now look directly at the northern half of this exact same atmospheric machine, where the identical jet stream configuration is currently unleashing a violent structural collapse across the Midwest. While Arthur systematically exploits these coastal and inland energy reservoirs to the south, the northern wing of this identical atmospheric pattern is initiating a major structural collapse across the American Midwest. 1,000 miles away, the Storm Prediction Center has issued a highly anomalous Level 4 out of 5 severe weather risk for parts of Illinois and Indiana, surrounded by an expansive Level 3 and Level 2 risk zone. This exceptional June designation is anchored by a 15% hatched tornado area, which explicitly flags the high probability of violent tornadoes capable of leveling well-built homes. Simultaneously, a 30% hatched wind area warns of hurricane-force straight-line winds exceeding 75 miles per hour, alongside a significant hail threat projecting stones greater than 2 inches in diameter. The structural driver behind this violent setup is a deep low-pressure system tracking into the Great Lakes, dropping to an extraordinary barometric reading of 990 millibars. A winter-grade low of this depth, combined with an accelerated jet stream running at speeds typically reserved for early spring, represents a setup seen maybe once a decade in mid-June. The calendar says summer, but the internal machinery overhead is executing a destructive springtime program, drawing immediate historical comparisons to notorious violent outbreaks of the past. The crucial analytical leap is recognizing that this severe Midwestern outbreak and the rule-breaking tropical storm to the south are not separate, coincidental events. They are the left and right hands of a single, continent-spanning synoptic engine. The intense 990 millibar Great Lakes low acts as a massive planetary gear, pulling a profound surge of warm, volatile Gulf moisture northward on its eastern flank to fuel the supercells in Illinois and Indiana, while simultaneously soaking the deep south to construct Arthur's Brown Ocean. Furthermore, the same upper-level trough carving through the country is both spinning up the Midwestern tornadoes today and positioning itself to mechanically pump and reload Arthur off the Carolinas by Friday. This single pattern places well over 1/3 of the nation, exceeding 120 million people, under a continuous corridor of severe weather threats as a cold front marches toward the eastern seaboard. To understand how this overloaded pattern became possible, we must trace the energy back to its primary origin, an unseasonably hot Gulf of Mexico. Having a named storm materialize this early in June points to a marine fuel tank that is full months ahead of schedule, influenced by a neutral but rapidly warming El Nino and La Nina cycle tracking at plus 0.48. Crucially, the Gulf is storing heat through a meaningful depth, preventing the storm from self-choking via cold water upwelling. This unseasonal warmth triggers the relentless physics of the Clausius-Clapeyron relationship, a textbook law dictating that for every 1 degree Celsius of atmospheric warming, the air's moisture capacity expands by approximately 7%. This thirstier sky is verified by near-record precipitable water readings between 2.1 and 2.6 inches ahead of Arthur, raising the absolute ceiling on how much water the sky can hold and dump. This invisible atmospheric loading translates directly into severe human consequences on the ground. The Weather Prediction Center has designated a Level 3 out of 4 moderate risk of excessive rainfall, projecting widespread totals of 2 to 5 inches and localized pockets of 6 to 9 inches across southern Mississippi, Alabama, and the Florida Panhandle. This rainfall will meet a 2 to 4 foot storm surge at the coast, locking the regional drainage systems and triggering severe freshwater flooding. The historical record is brutally clear. Disorganized, weakening systems, often the deadliest precisely because the public misinterprets a dropping wind category as a sign of safety, letting their guard down while the water rises indifferently. This threat is further compounded by rain-wrapped spin-up tornadoes forming overnight within Arthur's bands due to extreme low-level shear. This complex array of hazards has naturally triggered unscientific conspiracy theories, alleging artificial manipulation or steering of the storm. However, simple energy calculations thoroughly deconstruct these myths. The latent heat energy released by a modest tropical system completely dwarfs total human civilization output by a factor of billions, rendering any human intervention mathematically inconsequential. The real crisis is not a hidden hand, but a system operating at its physical structural limits. As Arthur serves as the opening act for a highly charged season, it leaves us with a sobering demonstration of a loaded atmosphere, showing that when the baseline boundaries of ocean warmth and atmospheric moisture are permanently shifted, the rules of nature are rewritten in the water.